Part 1 of Lesson 3 of Chapter 2 is on the remainder and factor theorems. We're going to be doing long division using polynomials. You should remember this from Algebra 2. It's pretty recognizable when you see the problems. Example 1 says use long division to factor the polynomials. It gives us a third degree polynomial. You can see right here, third degree polynomial, completely using long division if x minus 3 is a factor. So when we set up long division, we put the x minus 3 on the outside, and then 6x to the third minus 25x squared plus 18x plus 9. You want to make sure that the polynomial inside is written in descending order. So now we start off and we say what times x gives us the first term 6x to the third, and that would be 6x squared. So now when I take that 6x squared, I multiply it times the divisor and write it underneath. 6x to the third minus 18x squared. Now we have to draw a line and subtract the two polynomials. 6x to the third minus 6x to the third, they cancel out. The negative 25x squared, and then it becomes minus a negative 18. So that's a double negative right there. And that ends up giving us negative 7x squared. Bring down the next term, plus 18x. So now we ask ourselves what times x would give us the negative 7x squared. So that's going to be a negative 7x. Take that times each of the terms. We get a negative 7x squared plus 21x. Subtract the two. Notice I'm putting parentheses around the bottom set so that I remember to distribute that negative sign. It's going to give us a negative 3x. Bring down the last term and do it one last time. So what times x gives us the negative 3x? That would be negative 3. Now, when you're done with these problems, you should end up with a 0 at the end, which means it divides evenly. And the original problem says factor completely. My final answer is going to look like this. It's going to have an x minus 3, and it's going to have two other sets of parentheses in it. How do I know that? Because it's a third degree polynomial. So what we have to do next is take this guy, the quotient, and factor that out. So let me take the 6 and send it to the back. And then factor from there. Make up for sending the 6 to the back by dividing by 6. And that would give us x plus 2/6, x minus 9/6, which I would change into 3x plus 1. And let's see here, that's going to be 3 over 2, so 2x minus 3 are my other two factors. There is my factored solution. Try another example the same way. They're giving us a third degree polynomial right here. And they're telling us that one of the factors is x minus 6. So my final answer is going to look like this, x plus 6. And then I'm going to have two more sets of parentheses. That'll be my final answer. We've got to find those other two. We'll do that by using long division. Okay, as we start to do the long division, we'll have an x squared on top to begin with. Oops, made a mistake there. Let's fix that. X to the third plus 6x squared. Subtract the 2, and we get 1x squared. Bring down the next term, plus 4x. Next term for my quotient is going to be an x. We're going to get x squared plus 6x. When you subtract, you're going to get a negative 2x. Bring down the next term. Do it one last time. again, when you subtract, you should get a 0 at the end on these problems. So, we're almost done. Now we got to take this guy and factor it. Diamond problem, if you will. It's going to be a +2 and a -1. Those are my other two factors that I was looking for. And there's my final solution, a factored form of that third-degree polynomial. Now, example 2 is just more long division. Now we're not coming up with all the factors. We just have to do long division. But what's different about this is you can see that we're missing a term here. I'm going to use a different color. Anytime you're missing a term, you got to put a 0 coefficient on it. Otherwise your columns won't line up properly. So now that I'm set to do the long division, we're going to need a 3x squared from the first term. It gives us 9x to the third plus 6x squared. As we subtract, we're going to get negative 6x squared. Bring down the next term. Minus x. Negative 2x is the next value in my quotient. That'll give me negative 6x squared minus 4x. Subtracting would give me 3x. Bring down the last term. So we get a +1. Now another thing that's different on these problems now is you won't end up with 0 at the end. You could, but a lot of times you probably won't. So this ends up giving us negative 5. And so what we do is we go plus, you put the remainder over the divisor, 3x plus 2. So this is the answer we get when we divide those two polynomials. Last problem. Here we have a 4th degree divided by a 2nd degree. So it looks really hard, but it's just more terms to deal with. But it's done the same way. So there's my divisor. My dividend. Doesn't look like I'm missing any terms, which is good. So let's see, my first term of my quotient is going to be a 2x squared. Now when I subtract each of these from the term above it, looks like we're going to end up getting a negative 1x squared. Bring down the next term. Bring down the next term as well, because both the negative 4x to the thirds canceled out. So it looks like we're going to have just a -1. As we subtract each of these terms from the term above it, looks like we're going to get a 1x and then a -4. That's my remainder. So I put that remainder, x minus 4, over the divisor, x squared minus 2x plus 7. There is my solution, my quotient I get when I divide those two polynomials. 4th degree divided by 2nd degree gives you a 2nd degree quotient with a remainder of x minus 4. This is going to be the homework that you're going to start working on in class tomorrow. It's going to be collected Friday. This is part 1 of lesson 3 of chapter 2. The next part of this lesson will be coming tomorrow night.